This is not a hoax. This is not a joke. It is becoming clear that we hold in our hands the fate of the entire human race. Those of us alive today are part of a very small group, including us and perhaps a few generations to follow, who are responsible for the future of humanity. And if it turns out that we are alone in the universe, then even the fate of intelligent life may hang in the balance. No other humans have ever been in the unenviable position that we are. No humans who lived before were actually capable of wiping the human race from existence. No other humans were capable of screwing things up so badly and permanently. And those future humans to come won't be in this position either. If we fail and the worst happens, there won't be any future humans. And if we succeed and deliver the human race to a safe future, those future humans will have arrived at a place where they can easily deal with any risks that may come. We will have made existential risks extinct. Taking all of this together, everything seems to point to the coming century or two as the most dangerous period in human history. It's an extremely odd thing to say, but together, you, me, and everyone we know appear to be the most vitally important humans who have ever lived. And as much as is riding on us, we have a lot going against us. We are our own worst enemies when it comes to existential risks. We come preloaded with a lot of biases that keep us from thinking rationally. We prefer not to think about unpleasant things like the sudden extinction of our species. Our brains aren't wired to think ahead to the degree that existential risks require us to. And really, very little of our 100,000 years or so of accumulated human experience has prepared us to take on the challenge that we are coming to face. And a lot of the experience that we do have can actually steer us wrong. It's almost like we were dropped into a point in history we hadn't yet become equipped to deal with. Yet despite how utterly unbelievable the position that we find ourselves in is, the evidence points to this as our reality. The cosmic silence that creates the Fermi paradox tells us that we are either alone, and always have been, or that we are alone because no other civilization has managed to survive. If the latter is true, if the Great Filter has killed off every other civilization in the universe before they could spread out from their home planets, then we will face the same impossible step that everyone else has before as we attempt to move off of Earth. And if the Great Filter is real, then it appears to be coming our way in the form of the powerful technology that we are beginning to create right now. But even granting that the Great Filter hypothesis may be faulty, that we aren't alone, that there really is intelligent life elsewhere, we still find ourselves in the same position. We are in grave danger of wiping ourselves out. There doesn't appear to be anyone coming to guide us through the treacherous times ahead. Whether we're alone in the universe or not, we appear to be on our own in facing our existential risks. All of our shortcomings and flaws notwithstanding, there is hope. We humans are smart, wily, ingenious creatures. And as much as we like to think of ourselves as something higher than animals, those hundreds of millions of years of animal evolution is still very much in our nature. And when we're backed into a corner, that animal ancestry comes rising to the surface. We fight. We rail against our demise. We survive. If we can manage to join that creature habit to the intelligence we've evolved that really does make us different from other animals, then we have a chance at making it through the existential risks that lie waiting ahead. If we can do that, we will deliver the entire human race to a safe place where it can thrive and flourish for billions of years. It's in our ability to do this. We can do this. Some of us are already trying. And we've already shown that we can face down existential risks. We've done it before. We encountered the first potential human-made existential risk we've ever faced in New Mexico, of all places. On July 16, 1945, at just before 5:30 a.m., the desert outside of Alamogordo was the site of the first detonation of a nuclear bomb in human history. They called it the Trinity test. At the moment the bomb detonated, the pre-dawn sky lit up, brighter than the sun, and the landscape was eerie and beautiful, in gold and gray and violet, purple and blue. The explosion was so bright that one of the bomb's designers went blind for nearly half a minute from looking directly at it. By the blast site, the sandy ground instantly turned into a green glass of a type that had never existed on Earth before that moment. They called it Trinitite to mark the occasion, and then they buried it so no one would find it. On this day, at this moment, the world was brought into the atomic age, an age of paranoia among everyday people that the world could end at any moment. In less than a month, America would explode an atomic bomb over Hiroshima in Japan, and 65,000 people would die in an instant. Another 55,000 people would die from the bomb's effects over the next year. And 3 days after Hiroshima, America would drop a second bomb over Nagasaki, and another 50,000 people would die. But even before all of the death and destruction that America wreaked on Japan in August of 1945, even before the Trinity test that day in July, nuclear weapons became our first potential human-made existential threat when the scientists building the bomb wondered if it might accidentally ignite the atmosphere. Edward Teller was one of the leading physicists working on the Manhattan Project, the secret program to build America's first nuclear weapons. By chance, Teller was also one of the physicists that Enrico Fermi was having lunch with when Fermi asked, "Where is everybody?" and the Fermi paradox was born. Teller was also pivotal in the nuclear arms race that characterized the Cold War by pushing for America to create a massive nuclear arsenal. In 1942, 3 years before the Trinity test, Edward Teller raised the concern that perhaps the sudden release of energy that the bomb would dump into the air might also set off a chain reaction among the nitrogen atoms in the atmosphere, spreading the explosion from its source in New Mexico across the entirety of Earth. A catastrophe like that would burn the atmosphere completely off of our planet. And that would, of course, lead to the sudden and immediate extinction of virtually all life, humans included. Almost immediately, a disagreement over whether such a thing was even physically possible grew among the physicists on the project. Some, like Enrico Fermi, were positive that it was not possible. But others, like Teller and the future head of the project, J. Robert Oppenheimer, weren't so sure. Eventually, Oppenheimer mentioned the idea to Arthur H. Compton, who was the physicist that was the head of the project at the time. Compton found the idea grave enough to assign Teller and a few others to figure out just how serious the threat of accidentally burning off the atmosphere really was. The group that worked on the calculations wrote a paper on the possibility that the bomb could set off a nuclear chain reaction in Earth's atmosphere, igniting it. Even using assumptions of energy that far exceeded what they expected their test to produce, the group found that it was highly unlikely that the bomb would ignite the atmosphere. 2 years later, when the bomb was ready, they detonated it. The morning of the Trinity test, Enrico Fermi took bets on whether the atmosphere would ignite after all. It is to his credit that Arthur Compton took the possibility of the nuclear test igniting the atmosphere seriously. The scientists and military people working on the secret atomic bomb project had every incentive to keep pushing forward at any cost. At the time, it was widely believed that Hitler and the Third Reich were closing in on creating an atomic bomb of their own. And when they completed it, they would surely savagely unleash it across Europe, Africa, the Pacific, and eventually the United States. In 1942, when the idea the bomb might ignite the atmosphere was first raised, it was far from clear who would be left standing when the Second World War was over. And yet, Compton decided that the potential existential threat the nuclear test may pose would be the worst of any possible outcomes. He didn't call it an existential threat, but he knew one when he saw one, even the first one. Better to accept the slavery of the Nazis than to run the chance of drawing the final curtain on mankind, Compton said in an interview with the writer Pearl Buck years after the test in 1959. And so it would appear that the first human-made existential risk we ever faced was handled just about perfectly. But there's still a lot left to unpack here. Buck reported that Compton had drawn a line in the sand, as it were. He established a threshold of acceptable risk. He told the physicists working under him that if there was a greater than a 3 in a million chance the bomb would ignite the Earth's atmosphere, they wouldn't go through with testing it. It's not entirely clear what Compton based that threshold on. It's not even clear if the threshold was a 3 in a million chance or a 1 in a million. And some of the Manhattan Project physicists later protested that there wasn't any chance, that either Compton had misspoken or Buck had misunderstood. Regardless, the group that wrote the safety paper found that there was a non-zero possibility that the test could ignite the atmosphere, meaning there was a chance, however slight, that it could. It was possible for such a chain reaction to occur. After all, the atmosphere is made of energetic vibrations that we call particles, and those particles do transfer energy among themselves. But the energies involved in the nuclear bomb should be far too small, the paper writers concluded. It would take perhaps 1 million times more energy than their plutonium core was expected to release. For some of the scientists, the chance was so small that it became transmuted in their minds to an impossibility. They rounded that figure down for convenience's sake. The chance was so small that, to them, there might as well have been no chance at all. But as we've learned in previous episodes, deciding what level of risk is an acceptable level of risk is subjective. There are lots of things that have much less of a chance of happening than 3 in a million odds of accidentally igniting the atmosphere. If you live in America, you have a little less than a 1 in a million chance of being struck by lightning this year. You have a roughly 1 in 290 million chance of winning the Powerball. Each person living around the world has something like a 1 in 27 million chance of dying from a shark attack during their lifetime. Depending on your perspective, a 3 in a million chance of bringing about the sudden demise of life on Earth from a nuclear test isn't necessarily a small chance at all, especially considering the stakes. And yet, it was up to Compton to decide for the rest of us that the test was worth the risk. Arthur Hawley Compton, aged 60, living in Chicago, Illinois, a Nobel Prize-winning physicist, father of 2, and tennis enthusiast, was put in a position to decide for the rest of the 2.3 billion humans alive at the time that 3 chances in a million their project might blow up the atmosphere was an acceptable level of risk. The idea that a single person can make a decision that affects the entire world is a hallmark of existential risks. Not only the existential risk poses a threat, but the very fact that a single human being is making the decision, with all of their biases and flaws and stresses, puts us all at risk as well. There were a number of different pressure points that the people involved in the Manhattan Project would have felt, pushing them toward the decision to carry out the test. There were the Nazis, for one, and the pressure from the US military to save the world from the Nazis. Their careers and reputations were at stake. There was also the allure of a scientific challenge. No one had ever done what the people working on the Manhattan Project did. Up to the moment of the Trinity test, no one was entirely sure that a nuclear explosion was even possible. Consciously or not, these things influenced the decisions of the people working on the project. This is not to say that there was any cavalier disregard for the safety of humanity. They took the time to study the issue rather than just brushing it off as impossible after all. But the point is that just a handful of people working in secret were responsible for making that momentous decision. And those people were only human. It's also worth pointing out that a lot of the science that the safety paper writers used was very new at the time. The nuclear theory they were working off of was less than 40 years old. The data they had on fission reactions was less than 20 years old. And the first sustained nuclear fission reaction wasn't carried out until 1942, when Fermi held the first test on that squash court at the University of Chicago. And don't forget, there had never been a nuclear explosion on Earth before. All of that newness, by the way, showed up during the Trinity test, when the bomb produced an explosive force about 4 times larger than what the project scientists had expected. All of this is to say that the data and understanding of what they were attempting with the Trinity test was still young enough that they could have gotten it wrong. And we find ourselves in that same situation today. We see it in the types of experiments that are carried out in particle colliders and biosafety labs around the world. We see it in the endless release of self-improving neural nets. Our understanding of the unprecedented risks these things pose is lacking to a dangerous degree. Depending on how the chances of a risk changes, the threat it poses can get larger or smaller. But really, the reality of the threat stays the same. It's our awareness of it that changes. Awareness is the way we will survive the coming existential threats. There are 2 ways of looking at our prospects for making it to a state of technological maturity for humanity, where we have safely mastered our technology and can survive beyond the next century or 2. Gloom and doom, and optimism. The gloom and doom camp makes a pretty good case for why humans won't make it through this, possibly the greatest challenge our species will ever face. There's the issue of global coordination, the kind of like-mindedness that we'll have to create among every country in the world to successfully navigate the coming risks. Like we talked about in the last episode, we will almost certainly run into problems with global coordination. Some nations may decide that they'd be better off going it alone and continuing to pursue research and development that the rest of the world has deemed too risky. This raises all sorts of prickly questions that we may not have the wherewithal to address. Does the rest of the world agree that we should invade non-compliant countries and take over their government? In a strictly rational sense, that's the most logical thing to do. Rationally speaking, toppling a single government, even a democratically elected one, is a small price to pay to prevent an existential risk that can drive humanity as a whole to permanent extinction. But we humans aren't strictly rational. And something as dire as invading a country and toppling its government comes with major costs, like the deaths of the people who live in that country and widespread disruptions to their social structures. If the chips are down, would we go to such an extreme to prevent our extinction? There's also the issue of money. Money itself is not necessarily the problem. It is what funds scientific endeavors. It's what scientists are paid with. Money is what we will pay the future researchers who will steer us away from existential risks. The Future of Humanity Institute is funded by money. The problem money poses where existential risks are concerned is that humanity has shown that we are willing to sell out our own best interests and the interests of others for money and market share. Or more commonly, that we're willing to stand by and let others do it. And with existential risks, greed would be a fatal flaw. Everything from the tobacco industry to the fossil fuel industry, the antifreeze industry to the infant formula industry, all of them have a history of avarice, of frequently and consistently putting money before well-being, and on a massive and global scale. How can we expect change when money is just as tied to the experiments and technology that carry an existential risk? Also stacked against us is the bare fact that thinking about existential risks is really, really hard. Analyzing existential threats demands that we trace all of the possible outcomes that thread from any action we might take and look for unconsidered dangers lurking there. They require us to think about technology that hasn't even been invented yet, to look a few more moves ahead on the cosmic chessboard than we're typically capable of seeing.
Checkmate.
To put it mildly, we're not really equipped to easily think about existential risks at this point. We also have a history of over-reliance on techno-optimism, that idea that technology can save us from any crisis that comes our way. Perhaps even thinking that reaching the point of technological maturity will protect us from existential risks is nothing more than an example of techno-optimism. And as we add more existential risks to our world, the chances increase that one of them may bring about our extinction. It's easy to forget since it's a new way of living for us, but the technology we're developing is powerful enough and the world is connected enough that all it will take is one single existential catastrophe to permanently end humanity. If you take the accumulated risk from all of the biological experiments in the unknown number of containment labs around the globe, and you add it to the accumulated risks from all of the runs in particle colliders online today and to come, and you add the risks from the vast number of neural nets capable of recursive self-improvement that we create and deploy every day, when you take into account emerging technologies that haven't quite made it to reality yet, like nanobots and geoengineering projects, and the many more technologies that will pose a risk that we haven't even thought of yet, when you add all of those things together, it becomes clear what a precarious spot humanity is truly in. So you can understand how a person might look at just how intractable the problem seems and decide that our doom is complete. It just hasn't happened yet.
I think we can be a bit more optimistic than that.
This is Toby Ord again, one of the earliest members of the Future of Humanity Institute.
Yeah, I think that this is actually a clear and obvious enough idea that people will wake up to it and embrace it much more slowly than we should. But I think that we will realize that this is a central moral issue of our time and rise to the challenge.
But to begin to rise to the challenge, we need to talk about existential risks seriously. The way that anything changes, the way an idea or an issue comes to be debated and its merits examined, is that people start talking about it. If this series has had any impact on you, and if you have, like I have, come to believe that humanity is facing threats to our existence that are unprecedented, with consequences that on the whole we are dangerously ignorant of, then it is imperative that we start talking about those things. You can start reading the articles and papers that are already being written about them. Start following people on social media who are already talking about existential risks, like David Pierce and Eliezer Yudkowsky and Sebastian Farquhar. Start asking questions about existential risks from the people we elect to represent us.
I think we often feel that the powers that be must already have these things in hand. But when I've talked with government about existential risk, even a major national government like the United Kingdom, they tend to think that these issues, saving civilization and humanity itself, are above their pay grade and not really something they can deal with in a 5-year election cycle. But then it turns out there's no one else above them dealing with them either. So I think that there's more of a threat from complacency in thinking that someone must have this managed. In a rational world, someone would.
It's up to the rest of us then to start a movement. The idea of a movement to get humanity to pay attention to existential risks sounds amorphous and far off. But we've founded movements on far-off ideas before. If enough people start talking, others will listen. Just a handful of books got the environmental movement started, like the ones written by the Club of Rome and Paul Ehrlich, but especially Rachel Carson's 1962 book, Silent Spring, which warned of the widespread ecological destruction from the pesticide DDT. Carson's book is credited with showing the public how fragile the ecosystems of the natural world can be, and how much of an effect we humans have on them. Awareness of things like fertilizer runoff, deforestation, indicator species, concepts that you can find being taught in middle schools today, were unheard of at the beginning of the 1960s. Most people just didn't think about things like that. But when the environmental movement began to gain steam, awareness of environmental issues started to spread. Within a decade of Silent Spring's release, nations around the world started opening government agencies that were responsible for defending the environment. The world went from ignorance about environmental issues to establishing policy agencies in less than 10 years.
And I think that we could do some of that, and it really shows that it is possible to take something which is not really part of common sense morality, and then within a generation, children are being raised everywhere with this as part of just the background of beliefs about ethics that they live with. So I really think that we could achieve that.
There is much work to be done with environmental policy, that is definitely granted, but we are working on it. Nations around the world, on their own and together, are spending money to pay scientists and researchers to study environmental issues, come up with an up-to-the-moment understanding of them, and establish best practices of how to protect Earth from ourselves. The trouble comes when we decide not to listen to the scientists that we've asked to study these problems. Existential risks call for this same kind of initiative. We have to establish a foundation, provide a beginning that others to follow can build upon. Just like Eric Drexler posed the rather unpopular Grey Goo scenario regarding nanobot design, just like Eliezer Yudkowsky and Nick Bostrom identified that AI should have friendliness designed into it, just like others have raised the alarm about risks from biotech and physics, if we examine the problems we face, we can understand the risks that they pose. And if we understand the risks that they pose, then we can make an informed decision about whether they're worth pursuing. The scientists working on the Manhattan Project did the same thing when they took the possibility seriously that they might accidentally ignite the atmosphere. So they investigated the problem to see if they would. We don't at this point have a clue as to what the possible outcomes for our future technology may be. And trying to guess at something like that today would be like guessing back in the 1950s about what effects clear-cutting old-growth forests in the Amazon basin would have on global cloud formation. It's just too arcane a question for a time when we don't have enough of the information we need to respond in any kind of informed way. We don't even know all of the questions to ask at this point. But it's up to us alive now to start figuring out what those questions are. Working on spaceflight is another good example of where we can start. Among people who study existential risks, it is largely agreed on that we should begin working on a project to get humanity off of Earth and into space as soon as possible. Working on space colonization does a couple of things that benefit humanity. First, it gets a few of our eggs out of the single basket of Earth. So should an existential risk befall our planet, there will still be humans living elsewhere to carry on. And second, the sooner we get ourselves into space, the larger our cosmic endowment will be. One of the things we found from studying the universe is that it appears to be expanding outward and apart. Over deep timescales, the kind of timescales we humans will hopefully live for, that could be an issue, because eventually all of the matter in the universe will spread out of our reach forever. So the sooner we get off Earth and out into the universe, the more of that material we will have for our use to do with whatever we can dream up. We are not going to colonize space tomorrow. It may take us hundreds of years of effort, maybe longer. But that's exactly the point. A project that is so vital to our future shouldn't be put off because it seems far off. The best time to begin working on a space colonization program was 20 years ago. The second best time is today. We are working on getting to space, true. But there's a world of difference between the piecemeal efforts going on across Earth now and the kind of project we could come up with if we decided to put a coordinated global human effort behind spreading out into space. Imagine what we could achieve if humanity worked together on what would probably be our greatest human project. Imagine the effect that it would have on people across the globe if we worked together to get not a nation, not a hemisphere, but the human race itself into space. The same holds true with virtually every project for taking on existential risks. We should begin working on them as soon as possible to build a foundation for the future, and we should make tackling them a global effort. I hope by now I've made it abundantly clear that subverting scientific progress won't protect us from existential threats. The opposite is true. We need a scientific understanding of the coming existential threats we face to get past them. The trick is making sure that science is done with the best interests of the human race in mind. It's not something we commonly think of ourselves as, but you and I and everyone else in the world is a stakeholder in science. And this is truer than ever before with the rise of existential threats, since the whole world can be affected by a single experiment now. In a 1975 article in the Bulletin of Atomic Scientists, physicist H.C. Dudley criticized Arthur Compton and the Manhattan Project for their decision that a 3 in a million chance was an acceptable risk for detonating the first nuclear bomb. They were all rolling dice for high stakes, and the rest of us did not even know we were sitting in the game, Dudley wrote. The same is true today. In making assumptions about whether cosmic rays make an acceptable model for proton collisions in the Large Hadron Collider, or that forcing a mutation that makes an extremely deadly virus easier to pass among humans is a good way forward in virology, those scientists are making decisions that have consequences that may affect all of us. So we should have a say in how science is done. Science is meant to further human understanding and to improve the human condition, not to further the prestige of a particular scientist's career. When those two things conflict, humanity should come first. But the say that the public has in how science is done has to be an informed say. No pitchforks and torches. This is why a movement that takes existential risks seriously requires trustworthy, skilled, trained scientists to make our say an informed one. We rely on them for that. Science isn't the enemy. If we abandon science, we are doomed. If we continue to take the dangers of science casually, we are doomed. The only route through the near future is to do science right. And scientists aren't the enemy either. They have often been the ones who've sounded the alarm when science was being done recklessly, or when a threat emerged that had been overlooked. Those physicists who decided that 3 in a million was an acceptable chance of burning off Earth's atmosphere were the same ones who figured out that there was something to be concerned with in the first place. It was microbiologists who called for a moratorium on gain-of-function research after the H5N1 experiments. It was particle physicists who wrote papers questioning the safety of the Large Hadron Collider. If you are a scientist, start looking seriously at the consequences of your field. And if work within it poses an existential risk, start writing papers about it. Start analyzing how it can be made safe. Take custody of the consequences of your work. The people who are dedicated to thinking about existential risks are waiting for you to do that. This is Sebastian Farquhar.
To a certain extent, organizations like the FHI, the Future of Humanity Institute, their job is just to poke the rest of the community and sort of say, by the way, this is a thing. And then for AI researchers or biology researchers to take that on and to make it their own project. And the sooner and the more FHI can step out of that game and leave it to those communities, the better.
Many of these solutions are already being worked on. Scientists around the world are researching large problems and raising alarms. But since we have a limited amount of time, since we're racing the clock, we have to make sure that we don't waste time working on risks that seem big but don't qualify as genuine existential threats. And we can't tell one type from the other until we start studying them. The biggest sea change, though, has to come from society in general. We have to come together like we never have before. We have to put scientists in a position to understand existential risks, and we have to listen to what they come back and tell us. It is astoundingly coincidental that at the moment in our history when we become aware just how brief our time here has been and just how long it could last, we also realize that our history could come to an early permanent end very soon. At the beginning of this series, I said that if we go extinct in the near future, it would be particularly tragic, and that is true. Human civilization has been around only 10,000 years. And remember that a lot of people who think humanity could have a long future ahead of us believe that there could be at least 1 billion years left in the lifetime of our species. If we've created almost every bit of our shared human culture over just the last 10,000 years or so, developed everything it means to be a human alive today in that short time span, think about what we could become and what we could do with another 999,990,000 years. It is not our time to go yet. There is something we have to consider. The Great Filter has to this point been total. It is possible that even if we come together, even if humanity takes our existential risks head on, that it won't be enough. That there will be something we miss, some detail we hadn't considered, some new thing that grabs us by our ankle just as we are making it through and plucks us right out of existence. If we go, then so many unique and valuable things go with us. The whole beautiful pageant of humanity will come to an end. There will be no one to sing songs anymore, no one to write books, and no one to read them. There will be no one to cry, and no one to hug them when they do. There will be no one to tell jokes, and no one to laugh. There will be no friends to share evenings with, and no quiet moments alone at sunrise. Good or bad, everything we've ever done will die with us. There will be no one to build new things, and the things that we have built will eventually crumble into dust. Those energetic vibrations that make up us and everything we've ever made will disentangle and go their separate ways along their quantum fields to be taken up into new forms down the line in a universe where humans no longer exist. If we go, it seems that intelligence dies with us. There will be nothing left to wonder at the profound vastness of existence and appreciate the extraordinary gift that life is. There will be no one with the curiosity to seek out answers to the mysteries of the universe, no one to even know that the mysteries exist. There will be no one to reciprocate. When the universe looks in on itself, there will be nothing looking back at it. But as genuinely sad as the idea of humanity going extinct forever is, we can still take some comfort in the future for the universe. We can take heart that if we die, life will almost certainly continue on without us. Remember, life is resilient. Over the course of its tenure on Earth, life has managed to survive at least 5 mass extinctions that killed off the vast majority of the creatures alive on Earth at the time. The life on Earth today is descended from just that fraction of a fraction of a fraction of a fraction of a fraction of life that managed to hang on through each of the times death visited Earth. And every time, after death left, life poked its head back out, came back up to the surface, and began to flourish again. If we humans call death back to our planet, life will retreat to its burrows and to the bottom of the sea, to hide until it's safe to reemerge. And perhaps when it does emerge again, one of the members of that community of life that survives us will rise to take our place, to fill the void that we've left behind, just like we filled the void left after the last mass extinction. Perhaps some other animal we share the Earth with now will evolve to become the only intelligent life in the universe and take their chance at making it through the Great Filter. Perhaps someday they will build their own ships that will break their bonds to Earth and take them into space in search of new worlds to explore, just like we humans tried so long before. The End of the World with Josh Clark is a production from HowStuffWorks and iHeartMedia. It was written and presented by me, Josh Clark. The original score was composed, produced, and recorded by Point Lobo. The head sound designer and audio engineer was Kevin Senzaki. Additional sound design by Paul Fonarev. The supervising producer was Paul Decken. A very special thanks to Yumi Clark for her assistance and support throughout the series production, and to Momo too. Thank you to everyone at the Future of Humanity Institute, and thanks to everyone at HowStuffWorks for their support, and especially Sherry Larson, Jerry Rowland, Connell Byrne, Pam Peacock, Nathan Natoski, Tari Harrison, Ben Bolden, Tamika Campbell, Noel Brown, Jenny Powers, Chuck Bryant, Christopher Hassatosis, Eves Jeffcoat, Matt Frederick, Tom Butera, Chris Blake, Lyle Sweet, Ben Juster, John Goforth, Mark Frushauer, Brittany Bernardo, and Keith Goldstein. Thank you to the interviewees, research assistants, and vocal contributors, Dana Backman, Stephen Barr, Nick Bostrom, Donald Brownlee, Philip Butler, Coral Clark, Sebastian Farquhar, Toby Halbrook, Robin Hansen, Eric Johnson, Don Lincoln, Michelangelo Mangano, David Madison, Matt McTaggart, Ian O'Neill, Toby Ord, Casey Pegram, Anders Sandberg, Kyle Scott, Ben Schleyer, Seth Shostak, Tanya Singh, Ignacio Taboada, Beth Willis, Adam Wilson Katsibas, Michael Wilson Katsibas, and Brett Wood. And thank you for listening.